Let us understand second important approach that is used in FEM as principle of minimum potential energy. So this is the approach that considers the variational form and the use of integrals like this. So for complex geometries and general boundary and loading condition, it is very much difficult to obtain exact solution for these problems. So in such cases, this method are useful to get in solution. So potential energy, which is considered to be sum of total strain energy and the work potential, so it is summed up to get total potential. So for linear elastic material, the strain energy per unit volume in the body is given as area under stress strain curve, 1/2 transpose of stress terms and multiplied by strain vector. So total strain energy per unit volume over V is U dV, integral of these two terms. So for linear elastic material, the strain energy per unit volume in the body is defined like this. Total strain energy based on this integral over volume V U dV. So this integral terms gives the total strain energy. So work potential based on these loads, three different types of loads, is body force, traction, and the unit loads is given like this. So which are negative terms, minus integral V U transpose F dV minus U transpose TDS over surfaces, and summation of the terms, so U multiplied by Pi I from 1 to n. So these three contributes work potential terms, and the total potential energy based on these equations are like this, as the first part of this is strain energy and rest of the three components are the work potential terms. So this is the overall equation for total potential energy. Now Rayleigh's method is used considering this total potential energy method, and it is an approximate method involving construction of an assumed displacement field UVW at a point. So these are the UVW terms as displacement along U x direction, y direction, and z direction, summation ai phi I x y z, where I varies from 1 to L, aj phi j, wherein j varies from L plus 1 to m, and w a k phi k, wherein k varies from m plus 1 to n, and here n is greater than m and m is greater than L. I, aj, ak are the unknown Riesz coefficients, and phi I, phi j, phi k are the polynomial terms. So potential energy is actually evaluated, and minimizing this potential energy, small change in potential energy with respect to Riesz coefficients yields number of equations as del pi by del ai is equated to 0 yields first equation, similarly second and third equation, and these three equations are expressed in matrix form.